Assalamu alaikum and welcome to Mathcast with Faria Yusuf. The topic that we shall be doing today is from differentiation and it's going to be equation of tangent and normal. So in coordinate geometry, we have already done the equations for tangents and normals, and we know that if we are given a curve, then with respect to the curve, if there is a tangent at a point on this curve, let's call this point P with coordinates x and y. If we have a tangent over here, then with respect to the tangent, we can have a perpendicular to the tangent. So a tangent and then a perpendicular to the tangent. And obviously, if this is the tangent to the curve and this is a normal to the curve, which is going to be perpendicular to the tangent, then we know that there exists a relationship between the gradient of the tangent and the gradient of the normal. And this relationship is that if I have the product of both the gradients, meaning if I say it's the gradient of tangent times the gradient of normal, then the gradient of tangent times the gradient of normal, this should be equal to -1. So we already know that the gradient of tangent and normal, that means that the tangent gradient is actually the inverse of the normal gradient, negative inverse of the normal gradient, or we can say that the gradient of the normal is the negative inverse of the tangent gradient. So just for an example, if the gradient of a tangent is a 2, the gradient of the tangent is a 2, then I should know that the gradient of normal needs to be a -1 by 2. Or if I say that the gradient of tangent is a 3 by 2, then the gradient of normal needs to be a -2 by 3. Or if I say that the gradient of tangent is a -1, then the gradient of normal needs to be a +1. So we know all these relationships between the gradients of the tangent gradient and the normal gradient. So if it's the point P, x and y, then there exists a tangent, and to that tangent we can have the normal, and with that the gradient of the two shall be the product of the gradient of the two shall be equal to -1. So we are going to apply this concept to a given equation, and we will be doing the derivation, and we know that the first derivative is actually the gradient of the curve at that particular point. It's going to give us the gradient of the equation of that particular point here. Like if we do a simple question which says, so question 1, find the equation of the tangent and normal to the curve y is equals to 5x cubed plus x square minus 2 at the point -1 and -6. So that means we have the curve equation, and to this curve equation there is a tangent and a normal at the point -1 and a -6. So solving the equation, we have the curve equation here, which is 5x cubed plus x square and a minus 2, and to this there is a point which is -1 and -6, and on this point we have the tangent and we have the normal here, and we need to find the equation of the tangent and the normal at this point. So here we know that the first differential dy by dx, or the derivative, is actually the gradient of the curve and tangent at point P, which is -1 and a -6. So this means if I can get the gradient of this curve here, dy by dx of this curve here, and substitute the x as a -1, then I shall be getting the gradient of the curve and also the tangent gradient at that particular point, which is -1 here. So let's find the gradient. If y is equals to 5x cubed plus x square and a -2, then the gradient dy by dx shall be equal to, it should be 5 times 3 giving me a 15, x power reduced by 1 shall give me a 2, second term it should be 2 times 1 giving me a 2, x square reduced by 1 shall be just an x, and we know that the constant shall get eliminated. So this is actually the gradient of the curve equation, which is 15x squared plus 2x. It's going to be the gradient equation here. This here is actually going to be the gradient equation. So in this gradient equation, if I substitute x as a -1, which is for the point P, I will simply say that dy by dx when x equals a -1 shall be equal to 15 times -1 the whole square plus 2 times -1. Further, I can say that my dy by dx for x equals -1 shall be equal to 15 -2, or this gradient then shall be equal to 13. So this then is going to be the gradient when my x is equal to a -1 and y is equals to a -6. So here I should know that my tangent gradient shall be equal to 13. And if I know the tangent gradient, then obviously it's not difficult to find the gradient of the normal, which should just be the negative inverse of the tangent gradient. So this is how I shall be having the gradients of the tangent as well as the normal. So to make the equation of the tangent and the normal from coordinate geometry, we know that equation of a straight line, and in this case it's the equation of tangent, which is a straight line. This should be equal to y minus y1, which is equals to the gradient of the tangent times x minus x1. And in the same manner, if I'm supposed to get the equation of the normal, then again being a straight line, it should be equal to y minus y1, which is equals to the gradient of the normal times x minus x1. So this is the line equation which we should be knowing to find out the equation of a line here. So we have been given the point P, and the point P here is -1 and a -6. We know the gradient of the tangent, which is a 13. So if I substitute the two in the given equation, I should be having y minus -6, which is equals to 13 times x minus minus 1. Solving the equation, it becomes y plus 6, which is equals to 13 bracket x plus 1. Further, I can say it's a y, which is equals to 13x plus 13. I can bring this 6 on the right hand side, which becomes a -6 here. And I'll say that the equation of the tangent is 13x plus 13 minus 6, which will give me a 7. So this then shall be the equation of the tangent here. To get the equation of the normal, I shall be substituting the point P for x1 and y1. The gradient of the normal, we found the gradient of the normal as a -1 by 13. So these are the two things that I shall be substituting in this straight line equation. And then here I will say that this is going to be y minus -6, which is equals to -1 by 13. And it's going to be x minus minus 1 here. Further, I can say this is y plus 6, which is equals to -1 by 13, and then x plus 1. I can just multiply this y plus 6 by 13, and I'll be here left with negative x plus 1. This becomes 13y plus 13 times 6, which shall give me an 8, which then shall be equal to a -x and a -1. Or further, rearranging the equation, I can say it's a 13y plus x plus 78 plus 1, which should be equal to 0. Or further, I can say it's a 13y plus x and a plus 79, which should be equal to 0 here. So this then shall be the equation of the normal to the curve at the point P with coordinates -1 and a -6. So this is how simple it is to get the equation of the tangent and the normal to the curve at given point. So let's do another question. Question 2. Find the equations of the tangents to the curve y is equals to x squared minus x minus 12 at each of the points where the curve crosses the x-axis. Now, according to the question, we are supposed to find the equations of the tangents, meaning we have to find more than one equation of the tangent at each of the points where the curve crosses the x-axis. So this means that the curve is actually crossing the x-axis. This curve is crossing the x-axis at more than a point, and for those points we shall be finding out the equations of the tangents here. So to solve that question, another thing that we should be knowing here is that whenever any line crosses the x-axis, on the x-axis at all the points, we should be knowing now that at all points on this x-axis, all the points here, I can say that my y coordinate here becomes a 0. If these are the 3 points or any point on the x-axis, then I know that my y coordinate here becomes a 0. So that is why we say that the equation of the x-axis is y is equal to 0. So as it is crossing the x-axis, there is one thing that we should be knowing, and that is that my y shall be equal to a 0. So if my y equals 0, I should be able to get the x coordinates then. So if the curve equation given to us is y, which is equals to x squared minus x and a minus 12, and here my y is a 0, so I can say it's x squared minus x and a minus 12. And solving this equation, I should be getting x squared minus 4x plus 3x and a minus 12, which shall be equal to 0. I've just factorized the equation here. X common, left with x minus 4, plus 3 common, left here also with x minus 4, or I can say it's x minus 4 and x plus 3, which shall be equal to 0, or I can say x is equal to a 4 and it's equal to a -3. So these are the 2 points where we know that the curve is crossing the x-axis, which gives the y to be equal to 0. So this means that if the curve equation here is y, which is equal to, it's y which equals x squared minus x and a minus 12, then to have this tangent equation which they have asked us to find out, they have asked us to find out the equation of the tangent, then there are two things that I should be finding out. Number one, I should be finding out the gradient of the tangent, and then I should be finding out the point at which we have to have this tangent equation. So the point, I've already found out the point, it's a -3 and a 0, and I can call the other point as q, and that is having the coordinates as 4 comma 0. So we need to find out the gradient at these 2 points where my y is a 0, where the curve is crossing the x-axis here. So to find that, the first thing is to have the gradient of the tangent, and to have the gradient of the tangent I should be having my first derivative dy by dx, as dy by dx is actually the gradient equation. So the gradient equation with respect to x squared minus x minus 12 shall be, so it should be 2 times 1, which gives me a 2, and this 2 gets reduced by 1, 2 minus 1, which shall give me a 1 here. So here I can say it's a 2x minus, now x has a power which is a 1. So 1 gets multiplied with this 1 here. We know that the coefficient of x in this case is a 1. So I'll just be left with a 1 because I know that it's x to the power 1 minus 1 that gives me x to the power 0, and any number to power 0 gives us a 1. So there is no need of writing this as x to the power 1 minus 1 to the power 0. So I'll just be writing the gradient of negative x as a negative 1, and we know that the constant for the differentiation equation becomes eliminated. Therefore, I'm left here with just 2x minus 1. Now, there are 2 points. Number one, I can have my x coordinate as a negative 3. So, if I have my x coordinate as a negative 3, then here I can say that the gradient of the tangent shall be equal to 2 times negative 3, negative 1. And the gradient of the tangent here is going to be a negative 6, negative 1. Or I can say that this tangent shall be having the gradient which is negative 7. So this is one information that we have about the tangent, and in the same manner I can also substitute this x coordinate as a 4 in the gradient equation. So substituting x as 4 in the gradient equation, I will be having the gradient of the tangent, which shall be 2 times 4 times negative 1, or I can say it's 8 minus 1, or I can say that this is having the gradient value which is equals to a 7. So with the gradient values as negative 7 and a positive 7, if I just sketch the curve for the sake of understanding, then what I know here is that I have this curve here, and on the x-axis the curve was intersecting at p negative 3 comma 0 and also q at 4 comma 0. So these are the points where the curve was intersecting the x-axis here, and with respect to these points, the 2 points P and Q, we have the tangents. We have these two tangents here. This tangent at P equals negative 3, and this tangent with the x coordinate as a 4. And the gradient value of these two tangents was equal to a negative 7, and this here was equal to a positive 7. So that means if I'm supposed to get the equation of the tangent, then there are 2 points, negative 3, 0, for which the gradient is a negative 7. I know tangent equation is y minus y1, which is equals to the gradient times x minus x1. I can substitute x1, y1 as negative 3 and a 0. So it's y minus 0, which is equals to negative 6, and x minus minus 3. So this is equals to y, which is equals to negative 7, and then it's going to be a negative 21, or I can say it's y plus 7x plus 21, which is equal to 0. So this is one of the tangent equation that I should be having at point P with x coordinate negative 3. Similar, so for point Q, I should be carrying out the same method. I should say Q has coordinates 4 comma 0. The gradient of the tangent here shall be equal to a positive 7. To find the equation of the tangent, again I'll be using the equation which is y minus y1 equals gradient of the tangent times x minus x1. This becomes y minus 0, which is equals to the tangent gradient, which is a 7, and then x minus x1, which is a 4 in this case. So here I can say it's x, which is equals to 7x minus 28, or I can say it's y, which, or I can say it's y minus 7x plus 28, which shall be equal to 0. So these are the two tangent equations that I should be having on the 2 points where the curve was crossing the x-axis. Question 3. Find the equation of the tangent. So again, we are supposed to find the equation of the tangent to the curve y equals 5 minus 2x minus x squared, and the given point is a 1 and a 2. So to make the equation of the tangent, we know that we need just two things. Number one, we have to have the gradient of the tangent, and number two, we have to have the point x1 and y1 where the tangent exists. So in this case, we know that this point P, x1 and y1 is actually 1 and a 2. So it's just the gradient which is required to form the equation of the tangent, which is y minus y1 equals the gradient times So the gradient of the equation we know is y minus y1 equals the gradient of the tangent times x minus x1. So let's find the equation of the gradient of the tangent. So to find the gradient of the tangent, the curve equation is y equals minus 2x and minus x squared. If I differentiate it, then the first derivative is actually the gradient of the tangent. And here I should say that the 5 should get eliminated, minus 2x. The 5 gets eliminated, the constant for differentiation gets eliminated. Minus 2x, 1 gets multiplied by minus 2, which should give us a negative 2, and then x to the power 0 becomes a 1. So here I should just be having a negative 2 and then negative 2 times x to the power 1, as 2 here gets reduced by 1. So 2 minus 1 shall give me a 1 here. Or if I write the gradient equation at which I can say that my x value has to be a 1, because P at the point where we want the tangent is having the x coordinate as a 1 here. So if I substitute this x as a 1, I shall be getting my dy by dx, which then shall be equal to negative 2 times 1. This will give me the answer for dy by dx. That means it's the gradient of the tangent, which shall be equal to a negative 4. So to have the equation of the tangent, I have my point P, which is given as 1 comma 2. This is the point at which we have to find the equation of the tangent. I have this gradient value also, which is a negative 4. So in the straight line equation, if I substitute my y1 as a 2, gradient as a negative 4, and in place of x1 substituting a 1, here I shall be having y minus 2, which is equals to negative 4x and a positive 4, or I can say it's a y plus 4x minus 2 minus 4, which shall be equal to 0, or y plus 4x negative 6 shall be equal to a 0. So this then shall be the equation of the tangent to the curve at point P, which has coordinates 1 comma 2. So this is the solution for part A. Now to do part B. Part B says this tangent meets the x-axis. It's meeting the x-axis. So whenever it meets the x-axis, we know that the y-coordinate has to be a 0. So this tangent here, which has the equation y plus 4x minus 6 equals 0, it meets the x-axis at P, where my y is a 0, and then it meets the y-axis at Q. So meeting the y-axis at Q, that means on the y-axis, my x-coordinate needs to be a 0. So this tangent is actually crossing the x-axis at P, and it's crossing the y-axis at Q. So if I just have a sketch of this tangent, then I can see here that my equation of tangent that I obtained in part A was equal to y plus 4x minus 6, y plus 4x minus 6, which is equals to 0. Bringing it to the form y equals mx plus c, I should say it's y, which equals negative 4x and a plus 6. So again, I know that the gradient, sine of the gradient and the y-intercept, if I just sketch the curve, then these two things, they are of great importance, because we know whenever the gradient is a negative, then it has to be the line which slopes down. So this means that if it is the line which is sloping down, then with respect to the x-axis and the y-axis here, x-axis and the y-axis, it should be the line which slopes down. Therefore, this is how this tangent should be. Y equals negative 4x and a plus 6. The constant in the equation is actually the y-intercept. Therefore, on the y-axis, I can say this is my y-intercept, which shall be equal to a 6 here. So, question said that the tangent was meeting the y-axis at Q. So, from here, I should be having the q coordinates as a 6 comma 0, and then it was meeting the x axis at p. So here it should be having the coordinates as 0 comma 6. So I know the coordinates of q, it's a 0 comma 6, and it's meeting the x axis at p. So at the x axis we know that my y should be equal to 0 at the x axis. Y should be equal to 0. Therefore, I can say it's negative 4x plus 6, which should be equal to 0. Or I can say it's a negative 4x, which shall be equal to negative 6. This gets cancelled. X shall be equal to a 6 by 4. Or simplifying it, I should say it's a 3 by 2 here. I've just simplified it by 2. So x is equals to 2, meaning the P should be having the coordinates as 3 by 2 comma 0. So P has the coordinate which is 3 by 2 comma 0. So I have the coordinates of P, I have the coordinates of Q as well. Now the question said the tangent meets the x-axis at P. I have the coordinates of P, and the y-axis at Q. I have the coordinates of Q as well. Now I'm supposed to find the area of the triangle OPQ. So to have the area of the triangle OPQ, let's use the sketch here. So from this sketch, if it is the right angle triangle, I need to have the area OPQ. So for OPQ, I know that it is the right angle at O, and then I know that the area of this right angle shall be given as half into base into height, or I can say it's 1 by 2 into OP into OQ. OP here is the base, and it should be 3 by 2. OQ here shall be the height, and it should be equal to a 6. Therefore, substituting all these values, I should say it's a 1 by 2 times 3 by 2 times 6 here, or I can say it's a simplified by 2, that gives me a 3 there, and the area shall be 9 by 2, or I can say that the area is going to be a 4 whole 1 by 2 unit square. So this is how this question then gets solved. The curve y equals 5 minus x bracket 2 plus x crosses the x-axis at points A and B. The tangents at the points A and B meet at point C. So find the coordinates of C. So here again, let's underline the keywords. It's crossing the x-axis at points A and B. So at the x-axis, obviously we know that it should be the y, which should be equal to 0. And then we have, so let's start solving with respect to the y, which is equals to 0. And there are 2 points here, A and B. So if it's the curve equation, which is given as a 5 minus x and a 2 plus x, then if it's crossing the x-axis, this y needs to be 0. And I should be having here 5 minus x and a 2 plus x. With respect to that, I can say that there are two x values for x. There are two x values. One is 5 and the other shall be x equals negative 2. Meaning I can have the coordinate of A, which is a 5 comma 0, and I can have the coordinates of B, which is a negative 2 comma 0. So I have the coordinates of A and B. The second part of the question, it says the tangents at the points A and B meet at point C. Find the coordinates of C. So I have just drawn the two tangents to the curve. Like obviously there should be a curve which was there. So to the curve at point B, this was the tangent. To the curve at point A, this is the tangent. And these two tangents, when extended, according to the question, the two tangents, they are meeting at point C. And then we are supposed to find the point C. So if they are both meeting at point C, then I can say that this is the point C and this is the coordinate that we are supposed to find out. So here again, I can see that tangents are two straight lines, and when two straight lines are meeting at a point, we can solve the two simultaneous equations to get that intersecting point coordinates. So the first thing that comes to the mind should be to find the tangent to the curve at point P, tangent equation to the curve at point P. So for that, what I can say here is that my curve equation was actually y, which is equals to 5 minus x and 2 plus x. So to have the tangent equation, I should be having the gradient. And to get that gradient, I should be differentiating the curve equation. So to differentiate the curve equation, I should be having the curve equation, the expanded curve equation. And for that, if I solve the equation, then this becomes a 10 plus 5x minus 2x and a negative x square. Or I can say that this equation then is a 10 plus 3x and a minus x squared. So with this curve equation that I have, I should be having the first derivative to have the gradient of the tangent. So the first derivative 10 gets eliminated. 3x, the differential of 3x here should just be a 3, minus x square should give me the differential as a minus 2x. So this is actually the gradient equation that I should be having here. It's the gradient equation. The first derivative equation is actually the gradient equation. And then I have the point B and I have the point A also. So let's start working with B first. So B has coordinates 2 comma 0. So if that is the case, then I can substitute my x as a negative 2 in the gradient equation dy by dx, so that this becomes 3 minus 2 into minus 2, or I can say that this is a 3 plus 4, or I can say that the gradient over here dy by dx in this case shall be equal to a 7. Therefore, I can have the equation of the tangent at B. It's y minus y1, which is equals to the gradient of the tangent times x minus x1. And this should be at B, where our y1 is equals to 0. The gradient at this point is a 7 and our x1 was a negative 2. So y then shall be equal to a 7 times x plus minus, that gives negative negative, that gives me a positive 2, positive 2 times 7, that gives me a 14. So this is going to be the tangent equation at B. It's the tangent equation at B. In the same manner, I should be having In the same manner, I should be having the tangent equation at A. A has the coordinates as 5 comma 0, and we have the differential equation also. So A is having the coordinates 5 comma 0. Our differential equation dy by dx is 3 minus 2x. I can just substitute x as 5 in my differential equation to get the gradient value. So dy by dx then shall be equal to 3 minus 2 times 5, or I can say it's a 3 minus 10, or this gradient value here becomes a negative 7. So again, to get the gradient, to get the equation of the tangent at point A, it's x minus x1, y substituted as 0, gradient value as negative 7, and it should be x minus 5, or it's y, which is equals to a negative 7x and a plus 35. So these are the two equations that I should be having, and they should be meeting at point C. So if they are meeting at point C, then I know that if I solve the two equations simultaneously, solving the two equations simultaneously, this is equation 1 and this is equation 2. If I solve the two simultaneously, then I can say it's 7x plus 14, which shall be equal to a negative 7x plus 35, or I can say it's a 7x plus 7x, which shall be equal to a 35 minus 14, or it becomes a 14x, which shall be equal to a 21, or x then shall be equal to 21 by 14. Or further, I can say it's x, which shall be equal to a 3 by 2. Simplified by 7, I can say it's the x value, which is a 3 by 2. Meaning the two equations, the two tangents, they are meeting each other at point C, where the x coordinate of C here is a 3 by 2. So to get the y coordinate, I'll simply say I can just substitute this x in any of the two equations. If I substitute this in y equals 7x plus 14, then I can say it's y, which is equals to 7 times 3 by 2 plus 14 here, or I can say it's a 21 by 2 plus 14, or y equals a 21 plus 28 divided by 2, or this becomes a 49 by 2 here. So the C then should be having the coordinates C, which is point of intersection for the two tangents, should be having the coordinates as a 3 by 2 and a 49 by 2 here. So this then shall be the answer to this question for this point C here. So the next question says the normal to the curve. Now in this question we have the normal to the curve y is equals to under root x plus cube root of x at the point where x is equals to 1, and it's meeting the axes at, let's say it's p, which is p comma 0. So that means this is going to be the x-axis. With y as 0, it has to be the x-axis. And then we have another point. Let's say that point is a q with our x as 0 and our y coordinate as q. So this means here they are talking about the y-axis, because we know on the y-axis our x is a 0. So we are supposed to find the values of p and q. So these 2 points P and Q, they are present on the normal. These 2 points, they are the points which are there on the normal. So because they are saying it's the normal which meets the axes at P comma 0 and 0 comma Q. And also they have given us this point, which is x is equals to 1. So that means first we need to have the normal equation to solve for P and Q. So how to get the normal equation? Obviously, we have to have the equation of the normal. And to do that, I should be first having the derivative of the curve equation, and the curve equation here is y, which is equals to x to the power 1 by 2 plus x to the power 1 by 3. So if I get the derivative here, dy by dx, then I should say it's a 1 by 2 x to the power 1 by 2 and a negative 1, and then it should be a 1 by 3 x to the power 1 by 3 and a minus 1. Or further, I can say it's the derivative or the gradient, which shall be equal to 1 by 2 x to the power half minus 1, giving me a negative 1 by 2 plus 1 by 3 and x to the power negative 2 by 3 here. So this means that the gradient of the tangent in this case shall be 1 over 2 square root of x plus 1 over 3 x to the power 2 by 3. So as in the question, they have already said that this is where our x is equal to 1. This is what they have said. This is the information that I have, that my x shall be equal to 1. So if I substitute x as 1, then I shall be getting the gradient of the tangent, which then shall be equal to 1 by 2 square root of 1 plus 1 by 3. It's 1 to the power 2 by 3, which remains a 1. Or further, I can say it's the gradient of the tangent, which shall be equal to a 3 plus 2 divided by 6. Or I can say that the gradient of the tangent is a 5 by 6. So we have the gradient of the tangent, which is a 5 by 6. And from here, we know that the normal gradient shall be negative inverse of the tangent. Therefore, the gradient of the normal shall be equal to a negative 6 by 5. So we have the gradient of the normal. So here we have the gradient of the normal, which is a negative 6 by 5. In the question, it said x was equal to a 1. So here I have the gradient of the normal, which is a negative 6 by 5. X was already given, which was equal to a 1. To have the normal equation, I know that the normal equation is given as y minus y1, which is equals to the gradient of the normal times x minus x1. So substituting the normal gradient and the x1 value, this y1 value shall be left then. So to solve the y1 value, to get the value of this y coordinate, I know that my x is a 1. So in the curve equation, which was y equals square root of x plus cube root of x, if I substitute x as 1, then this y1 shall be y is equals to square root of x plus cube root of 1, square root of 1 plus cube root of 1, which shall be equal to a 2. So let's say that this point where the normal was touching the curve was 1 comma 2. So I can substitute this 1 comma 2 as y1 and x1 and also the gradient value, so that the equation of the normal becomes y minus 2, which is equal to negative 6 by 5 times x minus 1. 5 gets multiplied by y minus 2, negative 6 times x minus 1. This gives me 5y minus 10, which equals negative 6x and a plus 6, or 5y plus 6x. I've taken this negative 6 on the left side by changing the sign. So 5y plus 6x, which equals 6, and negative 10 from left to the right, giving me a positive 10. So here I can say that the equation of the normal is 5y plus 6x, which is equals to 16. So I have the equation of the normal, 5y plus 6x equals 16. The question was asking for p comma 0 and 0 comma q. This is the x-axis, the x-intercept. This is the y-axis, therefore the y-intercept. For p comma 0, I will be substituting y with 0 and x with p, so that I shall be getting 5 times 0, which is a 0, plus 6p, which equals 16, or 6p equals 16. Therefore, p then shall be equal to 16 by 6, or solving it by 2, I should say it's an 8 by 3 here. So the p value here is an 8 by 3. Solving for q, I should be substituting x with a 0 and y with a q. So it's 5 times q plus 6 times 0, which shall be equal to 16. 5q equals 16, or q then shall be equal to a 16 by 5. So this is how this question needs to get solved, and this is how we do differentiation and equation of tangent and normal for different kind of word problems. It's just that the understanding has to be there to get the gradient of the tangent, to get the gradient of the normal, and then the straight line equation, which can be for the normal and the tangent, which is y minus y1 equals the gradient times x minus x1. So this lesson was about the equation of tangent and normal, and in the next video I shall be doing the second derivative for the for differentiation. So best wishes, and let's end this video now. Allah Hafiz.